Number 11, we want to find the length of a curve. So let's remember the formula for the length of the curve. So we're going to integrate from a to b, square root, 1 plus derivative squared. All right, so here, let's find the derivative. So let's see, dy dx is equal to 2 times 3/2 x to the 1/2, or 3x to the 1/2. So that's our f prime of x. All right, so we're going to integrate from 0 to 1, square root 1 plus 3x to the 1/2 squared dx. So that's the square root of 1 plus 9x dx. Okay, we'll do a u substitution. We'll put u equal to 1 plus 9x. So we have du is equal to 9 dx, or 1/9 du is equal to dx. All right, let's get those limits of integration. So for x equal 1, we have u is equal to 10. And for x equals 0, we have u is equal to 1. All right, so we're going to integrate from 1 to 10. And we have square root u. And for dx, we're putting 1/9 du. So let's integrate u to the 1/2, do the power rule. So we have u to the 3/2 times 2/3. And we have this 1/9 over here. And we have our limits of integration, 1 to 10. All right, so we're just going to substitute in. All right, so we have, let me just multiply 2 over 27. And we have, substitute in 10 to the 3/2 minus 2 over 27, 1 to the 3/2, or 1. And we'll just leave it at that. In number 12, we're using the chain rule to get the derivative of e to the 5x squared plus 4. All right, so let's just remember if y is equal to e to the x, then the derivative is also e to the x. Okay, so in our case, we're going to do a chain rule. So the derivative is e to the, let's call this u, e to the u, e to the 5x squared plus 4, times u prime, or the derivative of u, times 10x. In b, we're going to take the derivative again, and this time we have a product, so we'll use the product rule. So the derivative is the first, x cubed, times the derivative of the second, derivative of e to the x is e to the x, plus the derivative of x cubed, that would be 3x squared, times the second times e to the x. In part C, we do implicit differentiation. All right, so first let's take the derivative of this term, and that's going to be a product rule. So we have the first times the derivative of e to the y, which would be e to the y, y prime, plus the derivative of the first, derivative of x is 1, times the second. Okay, so all this is the derivative of the first term. Now let's go to the derivative of y. That would be y prime. The derivative of x squared is 2x, equal the derivative of 10 is 0. All right, let's just solve for y prime. So we'll factor out y prime. So we have here x e to the y plus 1. Let's bring this to the other side. So here we have minus e to the y minus 2x. And now let's just divide by what's multiplying y prime. So y prime is minus e to the y minus 2x. And we're dividing by x e to the y plus 1. In number 13, we want the maximum points and inflection points of y equal x squared e to the x. All right, so we're going to take the derivative and set it equal to 0 to find critical points, and then test whether or not these are maximum or minimums. All right, so first the derivative, we use a product rule. So we have the first, that's x squared, times the derivative of e to the x, which is e to the x, plus the derivative of x squared, times the second, times e to the x. Let's factor out e to the x, and we can also factor out x. So let's factor out x e to the x. All right, so there we have x plus 2. And we'll find critical points by solving the derivative equal to 0. So from this factor we get x equal minus 2. And from this factor we get x equals 0. And remember that e to the x is never 0, so no other critical values come out from there. All right, now for the plus minus analysis. On the number line, let's put 0 for x equals 0 and minus 2. Sorry, minus 2 goes first. Let's put minus 2 and 0 on the number line. Okay, now remember that e to the x is greater than 0. It's always positive. All right. Okay, so now if we substitute in something larger than 0, like 1, everything here will be positive. All right, let's say we substitute in, let's say, a minus 1, something between 0 and minus 2. And here this is negative and this is positive. So we'll have negative here. And if we substitute in, let's say, minus 3, this is negative and this is negative, so that would be positive. So that means that y, our curve, is increasing. Here it's decreasing, and here it's increasing. So here we get a maximum, and here we have a minimum. Let's substitute into the original curve for the y value. So the minimum is at 0, 0, and the maximum is at minus 2, and then substituting here we have 4 e to the minus 2. Okay, so those are our max min points. All right, here we have an integral, which is a typical use substitution. Here's the inner function, and it has derivative 10x, and we have an x right here. All right, so we'll put u equal to 5x squared plus 2. du is 10x dx, and 1/10 du is 1/10 du is x dx. All right, let's integrate this now. Let's do the substitution. So for x dx, we're putting 1/10 du, and we have e to the u. All right, so this is integrate, and we get 1/10 e to the u plus c, because the derivative of e is e. All right, and just substitute back. In number 15, we have another use substitution. Here's the inner function is 7 plus e to the x, and the derivative is right here. That's the derivative of 7 plus e to the x is e to the x. All right, so we can put u equal to 7 plus e to the x. Du is e to the x dx. All right, so let's do our substitution. So for e to the x dx, we have du. And here we have square root u, or u to the 1/2. So this is equal to u to the 3/2 times 2/3. And now substituting back, we have 7 plus e to the x to the 3/2 times 2/3 plus c. Let me put the plus c here as well. Okay, and that's it.